Hello students, welcome to this lecture number 8 on state of matters. In this lecture again we are going to discuss a very important topic in this chapter. In the previous chapter we have discussed about kinetic molecular theory. One of the basic theory in the kinetic molecular theory, basic postulates we would say, that is the gas moves around each other. There is no fixed position of the gas molecules as we have observed in case of solid. In the solid, the position of the molecules are fixed, and that is the reason behind the gas do not have any volume or any shape. And as it is moving around each other, and with this moment, continuous moment, it collides with each other. So when it is going to collide, there must be a collision frequency, or there must be some collision number, and there must be one mean free path. Mean free path means when between the any two successive collisions, the path traveled by these molecules, that will be the mean free path. So in this lecture we will be going to discuss another these important things: what is collision frequency, what is collision number, and mean free path. And in previous lecture we have discussed about the velocity, and if you have not watched this lecture, you should watch it and it will be very much helpful to you. So today's lecture is collision frequency, number, and mean free path. So heading of this lecture we can write collision frequency, number, and the mean free path. Mean free path. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So, what do you mean by collision frequency? Let us first understand. If we want to define the collision frequency, how do we define? Collision frequency is represented as Z, and it is basically the number of collisions that is being taken place between the molecules of a gas in a fixed volume, that is 1 centimeter cube or 1 cc in 1 second. So we write the collision frequency, the number of collisions, is basically the number of collision taken place by the molecules in 1 second present in 1 centimeter cube or 1 cc of the volume of the gas. This is called the collision frequency. Now we want to derive a small equation regarding the collision frequency, and where you will find the molecular size, where we found the number of molecules in the 1 centimeter cube, or that is another thing. For that we want another important parameter, that is called the collision number. Collision number is represented by NC, and it is, what is this? This is also collision number. Collision number is what? The number of collision that is taken place by a single molecule, when the single molecule will strike with the molecules that present in a 1 cc or 1 volume of the gaseous material, At that time, in the 1 second, there will be 1 second and one single molecule that is going to give a collision number. And collision number, there is a, we can say this is √2 pi this is the collision number. Where you can see this terminology, that is V is average speed. V is average speed. Sigma, that is given by the molecular diameter. Molecular diameter is sigma, and N is the number of molecules. Number of molecules in 1 cc. So total number of collision that will be taken place, we can say that is NC into N. So this is the total number of collision. NC into N, and that we can put it, and it will be this √2 pi sigma square into N square. Now each and for one collision, there will be the involvement of the two molecules. So we can write the frequency, that is the collision frequency Z is equal to, what is this? Now we have to just divide by 2, that is given by NC into 2 into N divided by 2, and it will be given by this figure 1 by √2 pi sigma pi mu sigma square into N square. Okay, so this is the things. Now we know V is average velocity. So this is the expression, and from this expression we can also able to say the collision frequency is directly proportional to your that is the diameter, and that is the number of molecules present in your unit volume, and it is correct. When there is a higher number of molecules, that collision frequency will be higher, and it is the average velocity. Now we know the average velocity. Average velocity is given by this 8 by pi RT by M. So when we put this value here, what we get? 2 pi, we are just putting this value of V, that is average velocity, and it will coming around RT by M sigma square M. So we can have this, if we take this √8 out of root, then it will be 2 √2. So we get 2 from this, and with this pi and this pi, we will get this. Ultimately what we get? 8 has been coming out. So we get pi RT by M and sigma square and N square. So this is the relation between this sigma, this is the relation between the frequency of the collision, and between all these parameters, that is temperature, that is your Sigma is the diameter and number of molecules. Now we put this equation in the different way. Now we know what is N. N is basically the number of molecules. It is number of molecules. N is the number of molecules. Number of molecules per cc. So if we convert the number of molecules in terms of the pressure and in terms of the total number of molecules, then what we get? Because you know PV is equal to nRT, N dash RT, right? N dash is your mole. So from this we can say moles per unit volume. Moles per unit volume will be N dash by V is equal to, we can get P by RT. And we know for a 1 mole, number of molecules is a Avogadro number. So from this we can also get molecules per volume. Molecules per volume, and that is basically the N. Small n is equal to Pn0 by RT. That we can get. Okay. Now we put this here. This equation is we get, that is Z is equal to root over pi RT M. Here 2 is there, 2 is also there. So sigma square and N square. Okay. Now we put this value here. So we will get 2 root over pi RT by M, that is P N 0 the whole square by RT into sigma square. So we get a final expression for this collision frequency is this, and here we can see one thing very important, that we don't have to remember this total expression, that is not required. You will know the relationship. What is the relationship? The relationship we can say from this equation. So equation you can write here. Equation is here Z is equal to 2. From this expression we can also say the collision frequency. We can say collision frequency is directly proportional to the P square. P square means pressure of the gas. And it is also a very important thing that when we compress the gas, means pressure will be increased, right? So at that time what will happen? The number of molecules will increase. So when number of molecules will increase, that will going to give the higher collision frequency. So that is directly proportional. And also collision frequency is with the temperature, this relation will be there. These two things that you always remember. Which type of question comes? Let us understand first. One question I am giving. That is, it is giving at 1 atmosphere, the collision of molecules is Z, and what will be the collision? Shall be the collision what shall be the collision at 0.5 atmosphere pressure. Option is given, suppose 0.25 Z, 0.3 Z, 0.2 Z. None of the above. So this type of question comes. So what is called the one at 1 atmosphere collision of the molecule is Z. What shall be the collision at 0.5 atmosphere? So for that time you have to recollect this relation. The relation is what? The collision frequency is inversely proportional, directly proportional to the p square. That you can see here also the p square, and you are given the p square. So from this relation we can see Z1 by Z2 is equal to P1 square by P2 square. Right? Now here it is given Z1 is given, that is Z. We have to calculate Z2, and P1 is given which is 1 atmosphere, and P2 is also given, that is 0.5 atmosphere. So what we are going to get? Z1, if we put this value, that is Z by Z2 is equal to 1 by 0.5 the whole square. So it will be coming Z2 is equal to 0.25 into Z. Okay. So this will be the answer. Answer will be this. So this is very simple, but what is there? You have to know this. Right? Now we are going to discuss another very important thing, that is the mean free path. Now we are going to discuss the mean free path. What is mean free path? See, when the gas is moving randomly at the straight line at any direction, what is going to happen? It will continually colliding with the molecules. But between the two collisions, there will be a path traveled by the molecules where there is no collision, and this is called the mean free path. So what is the definition of mean free path? It is the distance. It is the distance traveled by molecules between any two So it is the distance traveled by the molecules between any two successive collisions. Suppose this is a gas. Here this is the molecule, and these molecules go there and here will collide, and between this length we will call the mean free path. Mean free path is represented by L. And how does it correlates with all those things that we are going to understand, with the pressure, with the molecules that we are going to understand. So mean free path length, mean free path is L equal to, we can write the average velocity divided by collision number. Right? Average velocity by collision number. Now we know already collision number is √2 pi n. So here √2 our velocity, average velocity will be cancelled out. So we are going to get 1 by root 2 pi sigma square into A. That we get. Now this N, that is the number of molecules per cc. Number of molecules per centimeter cube. And that we can already calculate it in the previous example, that will be going around Pn0 by RT. And N0 is basically the Avogadro numbers. This is Avogadro numbers. So we will put this value, we get L is equal to 1 by root 2 pi sigma square, and you will get here Pn0 and RT will be outside. So what we get, that is a very important relation we get. What we get? Now we can write this here also. From this relation we can able to say that mean free path is inversely proportional to the pressure and directly proportional to the temperature. So this relationship we have always remember in our mind while we going to solve this. So here we can write this here. One question is here that you can see. Question is, at 1 atmosphere pressure, mean free path is suppose A, and when we increase we have to calculate at 5 atmosphere pressure mean free path. Option is given here, A by 5, 5A, 2A, cannot predict. So at atmosphere, 1 atmosphere, the mean free path is A, and you have to calculate at 5 atmosphere what will be the mean free path. So for this we have to remember the relationship. So you can see that it is inversely related. Mean free path is inversely related to the pressure at the identical conditions when temperature and other things have been constants. So what is going to happen here? Thus we have to PL1 by L2, that is be P2 by P1, that is inverse relation. So we already know from here, P1 we know, P1 is what? P1 is giving here 1 atmosphere. P2 is what? It is giving 5 atmosphere. And L1 is given here A, and you have to calculate L2. So from that you can easily able to calculate that A by, you can easily calculate, and you can see that will be A by 5. Okay, so this type of question will ask. So I think that is very much clear to you what is mean free path and what is collision frequency and what is collision number and what is the correlation. That is more important, that we have to remember that how pressure is correlated with the collision frequency, how the diameter is correlated with the mean free path, that we are going to discuss. And another question that we are going to discuss now, question that we are going to give you, the very interesting question. Among the gases under the similar condition which shall be the highest mean free path. Among the gas, part of the gas is given neon, carbon dioxide, N2 and hydrogen. Among this gas, which will have the highest mean free path, highest, that what we discuss. How can we solve it? That you can see the relation again, you have to go again the relationship, that is L mean free path is inversely related to your diameter. This is the diameter, sigma square is diameter square. So we have to see which among these gas molecules having the lowest diameter. So lowest diameter will be hydrogen. So hydrogen will be a mean free path. Okay, that is the very important thing, very simple thing, but you have to know this. If you know, you can able to answer very quickly. Otherwise, it is not possible. So that is all for today's lecture. And in this lecture, we have discussed about the collision frequency, collision number, and the mean free path, and how they are correlated with the different variables like pressure, like temperature, like molecular diameters, all the things. Okay, thank you very much for watching. If you like this video, you can share to your friends. Thank you very much for watching.